Okay, so the complex numbers are written in the form of a real number and imaginary number. And imaginary numbers are any numbers that are created when we have a negative value x in the operation. So if we have, basically, I is square root of -1. And we can expand that to mean any other negative number inside there. For example, if I gave you the square root of -4, -4 can be broken down into two numbers. -1 times 4, which becomes square root of -1, square root of 4. We know that anytime we see a square root of -1, that becomes an I, and the square root of 4 is 2. So the answer is 2I. Square root of -36. Same thing. This is made up of -1 times 36. We can split them up. So we have square root of -1 times the square root of 36. So square root of -1 is I. Square root of 36. What times what is 36? 6. So the answer is 6I. What would this one be? Again, order of operations. Do special operations first. The square root of 4 is 2, and there's a negative out in front, so it's -2. Remember, imaginary numbers happen when the negative is inside the square root. If it's outside, it just stays there. If we had a negative square root of -4, order of operations, the negative stays out front. I'll leave it there. Inside this operation, we have -1 times 4, square root of -1 times square root of 4. So negative still in front. Square root of -1 is I. Square root of 4 is 2. So the answer is -2I. So that's how we use I's in our calculations to find complex numbers. The algebra of imaginary numbers. Remember, whenever you hear algebra of, all that means is we can do addition, subtraction, multiplication, and division. That's all it means. So here we're adding two imaginary numbers. What this means, it's all you do is follow the rules order of operations. First off, are there any coefficients in front of the parentheses? No, so we could just drop the parentheses. This positive goes inside there. Combine like terms. 3 plus 2 is 5. Positive 5i, positive 6i is a positive 11i. And there's your answer. Let's do another one. Negative 4 plus 3i plus 6 minus 5i. Again, there's no coefficient. There's only coefficient, only numbers in front of the parentheses are ones, and that's a plus. So I can just drop the parentheses. So this is a 1 in front of here, so it's positive 1 times 6 is positive 6. Positive times negative is negative. 1 times 5 is 5i. There's imaginary 1, so I distribute that. Combine like terms. Negative 4 plus 6 is, since 6 is bigger, the answer is positive. 6 minus 4 is 2. Positive 3, negative 5. 5 is bigger, so the answer is negative. 5 minus 3 is 2i. Let's say we had coefficients in front. You know, so we're still doing the addition operation. So we can't just drop the parentheses because we have coefficients. We have to distribute. That's a positive 2. Positive times negative is negative. 2 times 3 is 6. Positive and positive is positive. 2 times 2 is 4i. Positive times positive is positive. 3 times 3 is 9. Positive times negative is negative. 3 times 2 is 6. There's an I. Now we can combine like terms. Negative 6, positive 9. 9 is bigger than 6, so it's positive. So it's 9 minus 6 is 3. Positive 4, negative 6i. 6 is bigger, so the answer is negative. 6 minus 4 is 2i. So that's the addition. Let's look at subtraction. Three plus 2i minus 4 plus 5i. Now, again, we have no numbers in front of the parentheses, but when we're subtracting these two operations, whatever is behind the minus sign, that negative sign will get distributed throughout. Basically, what negative sign will do is change the sign of every number inside the parenthesis. So the first parenthesis has nothing, so I can just drop it. 3 plus 2i. This negative goes inside in front of both of those. So it's negative times positive is a negative 4. Negative times positive is negative 5i. Combine like terms. 3 minus 4. 4 is bigger than, there were different signs. 4 is bigger than 3, so it's negative because 4 is negative. 4 minus 3 is 1. Positive 2, negative 5. 5 is bigger, so it's the sign of 5 is negative. 5 minus 2 is 3i. And there's that answer. Okay, we have a subtraction problem again. So, but we have coefficients. We have to get rid of the coefficients first. Negative, again, remember, when you have a negative, these are going to change. Let's see how. Negative times positive is a negative. 2 times 3 is 6. Negative times positive is a negative. 2 times 5 is 10. Negative times negative is a positive. 3 times 2 is 6. Negative times positive is a negative. 3 times 5 is 15. Notice how these signs are different than those because the negative sign changes them. Combine like terms. Negative 6 plus 6, they cancel. Negative 10, negative 15, they're both negative, so I add them. 10 plus 15 is 25i. All right, that's the same concept there for all. So now let's look at the multiplication of imaginary numbers. Here's where the rules are going to start changing a little bit. 2 plus 3i. Let's first look at monomial. Oh, without the I. Let's just first try just a real number on the bottom. Here, we can split those up. So it becomes 1/2 plus 3/4 I. Things change whenever we have an I on the bottom. Remember earlier in chapter 1 when we talked about radicals, square roots. You cannot have a square root on the bottom. So what we have to do is multiply the top and bottom by the square root. Because negative radical 3 over radical 3 is only 1, so I'm just going to multiply by 1. So I have square root of 6 times the square root of 3. Square root of 3 times square root of 3 is 3. Six times 3 is square root of 18. 18 is made up of 2 times 9, which becomes square root of 2 times square root of 9 over 3. Square root of 9 is 3, so the 3's cancel. The answer is square root of 2. So we have to do something similar to that with imaginary numbers. Whenever you have an I on the bottom, we have to multiply the top and bottom. No, not rebuff. We just multiply by I. If we multiply both sides by 5, top and bottom, eventually those 5's will cancel. Like these 3's cancel. So we just multiply top and bottom by I. So I times 3 is 3i. Negative times positive is negative. 5i times I is 5i squared. 5i times I is 5i squared. All right. Those you cannot cancel. The thing about imaginary numbers, I cannot have an exponent. So we have to do something about this. We cannot have an exponent on I. Let's see what to do. We're going to come back to this one in a second. Let's see what happens. What is I squared? We know that I is the square root of negative 1. So if I square both sides, the square root and the square cancel, so I squared becomes -1. So there's another, whenever we have an I squared, we just replace it with a -1. So in our example, we had 3i minus 5i squared over 5i squared. 3i minus, remember, I squared is -1. I squared. Basically, all I squared does, I squared changes the sign of the coefficient, of its coefficient. Since it's -5i squared, it's going to change it to plus. Since a +5 down here becomes a -5. So this negative in the bottom goes on top. Remember, you never want to have a negative on the bottom, so the answer becomes -3i, distribute this, minus 5 over 5, which can be rewritten -5 minus 3i. The reason we'd like to rewrite like this, because remember, imaginary numbers, or complex numbers, are written like that. So whenever you have an I, it always comes behind. So whenever you have exponents with i's, things change. So the rule here, if you have monomial in the denominator, that's the bottom number, that is imaginary, then multiply the top and bottom numbers by I. If you have a monomial on the denominator, a single number, like we had here, it's a single number, then multiply top and bottom by I, because that'll get rid of the I on the bottom. This is called rationalizing the denominator. We're going from an I to a non-I term. It's called rationalizing the denominator. Let's take another example. What if you just had that? 2 plus 3i over I. Again, we have an I on the bottom. So we have to multiply the top and bottom by I. So I times 2 is 2I. Positive, positive is positive. I times 3I is 3I squared. I times I is I squared. So whenever you see an I squared, just put a negative 1 in place there. Again, as I said, I squared, all it does is change the sign of the coefficient. So positive 3 times negative 1 becomes negative 3. And this one is negative 1. So this negative on the bottom changes the signs of the top numbers. So that's the bottom's 1. So put it in the right order. So it's 3 minus 2I there. So that's if you have a monomial on the denominator. Rationalize the denominator if the denominator is a complex number. Remember, a complex number is a plus bi. It has both the real and the imaginary part. If the denominator is a complex number, multiply the top and bottom equations by the conjugate of the denominator. The conjugate is simply this. Change the sign of the coefficient of I. That's all a conjugate is. So to rationalize an equation, if we have a complex number on the bottom, multiply top and bottom by the conjugate. So if I had 3 plus 5i, the conjugate is 3 minus 5i. Just change that sign. Negative 6i plus 2, the conjugate is positive 6i plus 2. It's just the sign in front of the I term. All right, let's look at an example. All right, so we have 4 over 2 plus 3i. Since that's a complex number, we have to multiply the top and bottom by the conjugate. So we have the same numbers, 2 and 3i. Since that's a plus in front of the I, we have to put minus. Again, this times this, this over this is still 1. We're not changing the number, we're just changing the way it looks. Now we multiply the top and bottoms. 4 times 2 is 8. Positive times negative is negative. 4 times 3 is 12i. Now on the bottom, we have to FOIL. We have to multiply these two across. And again, we'll go through those rules in a second. So everything in the first parenthesis multiplies to everything in the second parenthesis. First term, 2 times 2 is 4. So positive 2 times negative 3 is negative. 2 times 3 is 6i. So that one, now's the other one. It's a positive 3i. Positive times positive is a positive. 3 times 2 is 6i, so it's a 6i. Positive times negative is a negative. 3 times 3 is 9. I times I is I squared. The top is 8 minus 12i. Fix the bottom. Negative 6i plus I. Those cancel. The I squared is a negative 1, which changes the sign of its coefficient, so it becomes a plus 9. So our answer, 8 minus 12i over 13. And there we have it. You notice how, that's the reason when we multiply the conjugate, it gets rid of all the i's. Because this I is positive, this I is negative, it'll wash themselves out. Let's look at another one. So on the bottom we'll have this. All right, so let's look at this. We have a complex number on the bottom, so we have to multiply top and bottom by the conjugate. Again, only one we'll worry about is the I, so leave the negative 4 alone, the constant, leave it alone. Again, the last part's going to be 3i. Since that's a negative, it has to be opposite inside these. Basically, it's exactly the same thing except the sign changes. And these have to be the same, but it has to equal 1. Multiply. Positive times negative is negative. 3 times 4 is 12. Positive times positive is positive. 3 times 3 is 9i. Now do the second one. Positive times negative is negative. 2 times 4 is 8i. Positive times positive is positive. 2 times 3 is 6. I times I is I squared. Do the same thing on the bottom. Negative and negative is a positive. 4 times 4 is 16. Negative times positive is a negative. 4 times 3 is 12i. So that's the first one. Now the second term. Negative times negative is a positive. 3 times 4 is 12. There's an I. Negative and a positive is a negative. 3 times 3 is 9. I times I is I squared. Combine like terms. Negative 12. Positive 9 minus 8. since 9 is bigger, it's going to be positive. 9 minus 8 is 1, so it's just I. Plus 6I squared. 16, negative 12I, positive 12I cancel, minus 9I squared. Remember, the I squared, all it does is going to change the coefficient, the sign of the coefficient. So it's negative 12 plus I. It used to be a plus 6, now it's a minus 6, because that I squared changed it. 16, the I squared changes that, so it's plus 9. You notice, whenever we have complex numbers, the bottom equation is always going to be a positive, because it's going to be pluses in front of that the coefficient. Negative 12 minus 6, they're both negative, so I add them. 12 and 6 is 18, plus I. 16 plus 9 is 25. And there we have it. There's our answer. So, yeah, and we went through the multiplication when we did this. I know I started off talking about multiplication, but here they are. I knew we were going to have to do that eventually, so. You only have to have complex conjugates on fractions. If we just did multiplication, 3 minus 2I times 5 plus 6I. Positive times positive is a positive. 3 times 5 is 15. Positive times positive is positive. 3 times 6 is 18. I. Negative times positive is negative. 2 times 5 is 10, and there's an I. Negative and positive is negative. 2 times 6 is 12. I times I is I squared. Combine like terms. Positive 18, negative 10. 18 is bigger, so it's positive. 18 minus 10 is 8I. This I squared changes that sign. 15 plus 12 is 27. Plus 8, and there's your answer. All right, so that's the algebra of complex numbers. Remember, I said you cannot have any exponent on I. Because we know that I, because what if I ask you, what's the answer going to be? Well, let's build this up. We'll come back to this one in a second. So we know that I is the square root of negative 1. Or it's just I. Because we're not going to write square root of negative 1. If we just have an I, we write I. That's just I. I squared, if we square both sides, then we get negative 1. I cubed. I cubed is made up of I squared times I. I squared is negative 1 times I is negative I. I to the fourth. I to the fourth is I cubed times I. Well, what's I cubed? I cubed is negative I. Whenever you see an I cubed, it's a negative I. So that's negative I times I is negative I squared. But we know that I squared is negative 1. So it's a negative, negative makes it a positive. So we know I by itself is I squared is negative 1, I cubed is negative I, and I to the fourth is 1. Notice there are no exponents in the final answers. Let's go on further. Let's look at a pattern. Let's look until we find a pattern. What's I to the 5 made up of? It's made up of I to the fourth times I. What is I to the fourth? 1. Times I times 1 is I. I to the 6th is the previous one, I to the 5th times I. So it's I to the 5th is I times I is I squared. Well, we know from I squared at negative 1. Almost done, promise. I to the 7th is made up of I to the 6th times I. What is I to the 6th? It's negative 1 times I is negative I. I to the 8th is I to the 7th times I. I to the 7th is negative I times I. Negative I times I is negative I squared. We know I squared is negative 1. Negative is positive. So there we have it. Here's the pattern. Let's look at all these without the stuff in the middle. So we start off with I. Then I squared is negative 1. I cubed is negative I. I to the fourth is 1. I to the 5th is I. I to the 6th is negative 1. I to the 7th is negative I. And I to the 8th is 1. If we notice, the patterns repeat themselves. I, negative 1, negative I, 1. So they repeat themselves in groups of 4. So to solve this one, we take the exponent and divide it by 4. We're looking for the remainder. So how many times is 4 going to 35? We know 4 times, say, 8 is 32. So 4 times 8 is 32, so that means there's 3 left over. Remainder 3. This is what we want. The remainder tells us what we're going to have. Remember our pattern here. The pattern is, if you want to erase, you would yell I1, and the middle 2 are negative. So the first column is the remainders. If the remainder is 1, the answer is I. If the remainder is 2, it's negative 1. If it's 3, it's negative I. If there's no remainder, it's a 1. So since our remainder is a 3, our answer is going to be negative I. So we see the pattern here of I1, the middle 2 are negative. So if the remainder is 1, it's the top one. If it's 2, it's the second one. 3 is the third one. If there's no remainder, it's the last one. And the reason you divide by 4 is because these repeat in groups of 4. So let's look, if I gave you I to the 76th, take 76 divided by 4. 4 goes into 7 once, with 3 left over. So how many times does 4 go into 36? 9 times 4 is 36, and there's no remainder. Since the remainder is 0, the answer is 1. So that's the complex number. That's how we use them. And we use them pretty much whenever we have a radical, a square root, or a cube root, or no, it's a square root, an even root to the negative number inside there. All right. Section 2. Quadratic equations. Functions, zeros, what was the other ones? Don't have to worry too much about models and zeros. The quadratic equation is any equation where 2 is the highest exponent on x. In Chapter 1, we talk about linear equations. Y equals mx plus b. Notice there's no exponent anywhere in the equation. That's how we know it's linear. A quadratic equation looks like this. That's a standard form. The largest exponent on x is 2, where a, b, and c can be any numbers. They're coefficients. And when we solve them, we need to have it equal 0. We've discussed the graph and the domain and range of this function. So we know that I could put positive, negative, or 0 inside of x, and it won't violate any rules of math. And since it's squared, if I put a negative number in there, it's always going to be positive. So the answer, the graph looks like this. It's a parabola. Parabola. The number at the lowest point, or highest point behind the graph, is called the vertex. Number of possible solutions for a quadratic. Well, that's going to come for us looking at the possible graphs. A quadratic equation can look like this. When we say solutions, we're talking about the x-intercepts. So when we talk x-intercepts, we're talking about solutions. So we can have two solutions. It can only touch the graph, the x-axis in only one place. That means we have only one solution. Or it could be off the x-intercept. We have no solutions. Okay, let me back that up. We'll have no real solutions. We can have imaginary answers. So an equation like this, if it crosses at 2 points, then we'll have two real solutions. If it touches at 1 point, we'll only have one real solution. But if it doesn't touch the graph anywhere, we're going to have no real solutions. We are going to have two imaginary solutions. Okay, now, here's what I'll get to now is determining the maximum number of solutions possible. This doesn't really require any math. It's just observation. Look at the largest exponent in the equation. That is the maximum number of solutions possible. So when you look at an equation, any type of equation, looking at the highest exponent, the largest exponent, will tell you how many solutions we can have, maximum. The largest exponent is also called the degree of the equation. So to determine the maximum number of possible solutions, look at the largest exponent, the degree of the equation. That tells you the maximum number of possible answers. Let's look at this. Well, we know so far we discussed two types, linears and quadratics. A linear equation looks like that. What's the largest power on x? 1. How many times does the graph cross the x-axis? 1. A quadratic equation looks like this. We discussed the most it can have are 2 answers. Well, that's what that tells us. So extending that, If I give you this equation, how many solutions can we have? How many solutions are possible? Well, look at the entire equation. Okay, look at the whole thing because it could be mixed up. What you always want to do is put it in descending order. So the largest exponent, next one. So before you determine answer in all these questions or any answers, always put them in decreasing order. So since that's a 4, we're going to have at most 4 possible solutions. That means the graph of this equation can cross the x-axis at the most 4 times. Can cross the x-axis at most 4 times. Since it's the 4th, there, 1, 2, 3, 4, which means both ends have to point in the same direction, either up or down. Or the answer could look like this. The graph could look like this. 1, 2, 3. Or we could look like this. 2 solutions. Or 1 solution, or no solutions. So the maximum number is 4, and go all the way down to no solutions. And that's for even degrees. Whatever the even, if you have an even number as the highest exponent, that's what's going to happen. If you have an 8, you'll have at most 8 and at least 0. If you have an odd degree, let's say x cubed, x squared. That's the highest. This is an odd exponent, odd degree. The only way that can possible is if both ends point different directions. So for odd degree equations, both ends point opposite directions. For even degrees, both ends have to point the same direction. So we can have at most 3. 2 or 1. So max 3, minimum 1 solution. But you have to have at least 1 because they point different directions. One direction has to cross the x-axis. So once you get to a point where you don't even have to know how to do stuff, just looking at the equation, you can tell me, okay, how many answers can we have? What's the basic shape? If you have an even degree, it's always going to look like this. Since both ends have to go to the same direction, it'll look like this. Odd degrees, they have the opposite direction. So we know this one, the y-intercept has to cross through 2. Because that's the constant. In this one, it has to cross through 1. But we'll continue this on Wednesday. Okay, everybody. I hope that helped. If you have any questions, just shoot me a remind message. Good luck, everybody.